This is the beginning of section 9.2, systems of linear equations with two variables. It is very close to what we just did in the last section. So here's a little thing about how many solutions you can have when you have two linear equations with an x and a y. There could be exactly one, no solution, or infinitely many solutions. And these are the different kind of pictures that they look like. One solution would be intersection at one point, no solution is parallel lines, infinitely many solutions are lines that are actually on top of each other. So you're still going to use method of elimination or substitution. So this one I'm actually going to solve for y and then substitute in. So we will get 13x is 52, x is 4. I'm going to plug back in, get y is 16. So this one has one solution. For this one, I'm going to use the method of elimination, and I'm going to choose to eliminate the y's. So I'm going to multiply the top one by a 5, bottom one by a 3. And go ahead and add those two up. X's and y's both go away, which means the left side is equal to 0. The right side is equal to 47. That is not true, which means that this has no solution. Infinitely many solutions. So I'm still going to do elimination again. I'm going to get rid of x's. I'm going to multiply the top one by 3, the bottom one by a negative 2. Oops, 3x. That's not true. So we get 6x minus 18y equals negative 70, positive 72. And then the bottom is negative 6x plus 18y equals negative 72. That one's the negative. So we add x's go away, y's go away, leaving 0. 72 and negative 72 is 0 again, which means infinite. Okay, since it means infinite, we have to actually go further with these. I'm going to take the first equation and solve it for y. So move 2x over. Oh, that's a y. Those are x's, those are y's. Minus 4. Okay, so our points on our line, for every x, our y's are 1/3 x minus 4. That's the actual answer right here. Right there. That's the answer, and then telling me it's infinite. Both parts. You need both parts. Now we have some word problems. Oh, I didn't need to go. I just need to move down. Identify the variables, express unknowns, set up equations, and then solve. It's like solving any other word problem. Here we have a woman. She's rowing a boat upstream from one point on the river to another 0.7 miles away at 1.25 hours. And then the return trip, traveling with the current, takes only 50 minutes. So we're talking about speed. We're talking about her speed in the boat and the speed of the river. So rate 1 plus rate 2 will be what we're doing on our way back. And then rate 1 minus rate 2 is what's going on upstream, because the rate 2, let me label this. Rate 1 is our boat. Rate 2 is the current. So this current's actually going to slow us down going upstream, but help us travel when we're going downstream. So our speed will be faster. So since we're talking about rates, we have distance equals rate times time. Distance divided by time is our rate. So when we're going downstream, we went 7 miles in 50 minutes. 7 miles in 50 minutes, but our rate is in hours, so this is like 5, 6, 50 minutes out of 60 minutes. And then on the way upstream, we have 7 miles in 1.25 hours. Well, they're already set up where we could just eliminate our 2's. This number, 7 over 5, 6, and plus 7 over 1.25, magically comes out to be 14. So our one is 7. The rate of the boat is 7. And then 7 minus, to figure out the other one, plug it back in and solve one of those mini equations, and it comes out that the rate of the current is 1.4. A woman, oh, similar question. Almost like same exact thing. Okay, so the boat minus the current is going to be what is going upstream. And it's 4 miles in 3 hours. The boat plus the current is what is going downstream, 4 miles in 2 hours. So our R2's go away. 4/3 plus 4/2 is 10/3. So our rate of our boat is 5/3 miles per hour. When you plug it back in to get the rate of the current, it ends up being 1/3. Next, we have a mixture. A veneer fortifies wine that contains 10% alcohol by adding 6% alcohol solution to it. As a resulting mixture, the alcohol strength is 12% and fills 1,100 1-liter bottles. How many liters of wine and of alcohol does the solution have? Well, it's wine and alcohol, right? So wine, alcohol, 1,100 liters. Or it's, sorry, to get the wine, it's alcohol and alcohol solution. So 10% alcohol plus 60% solution is going to equal 12% of our 1,100. Okay. So I can actually multiply the second equation by a -10 to get back to a 1. So let me rewrite these. So I'm going to leave the top one. And then we get -x minus 6y equals -1320. And my x's go away. I get -5y, -220. So y is 44. Plug it in and you get x, 1056. So this is the alcohol. That should be now. And that's the solution. Alcohol solution. And then we have a question about peanuts and cashews. Peanuts cost $4 per pound. Cashews cost $7.50 per pound. I'm going to buy a 5-pound bag of peanuts and cashews and pay $23.50 for the bag. How many pounds of cashews are there? Well, if I say peanuts are X, cashews are Y. So the pounds, X plus Y equals 5. Then we got to put the money in. So 4X plus 750Y is 2350. If I want to look for cashews, I really want to get rid of my X. So I'm going to multiply the top one by -4 to get rid of X. So my X's go away. 350Y is 350. So I bought 1 pound of cashews. And that means if I plug this back into the first equation, X plus Y equals 5, I bought 4 pounds of peanuts. That's the last. Is there one more page? No, that is the end. That's the end of this section.